Give a top AI model a real bug to fix, but hand it only the issue, no access to the code, no way to run anything. It's helpless. Not because it's dumb, because by itself a language model cannot open a file, run a test, or take a single action. It can only produce text. Everything that turns it into something that actually fixes the bug is a wrapper called harness. And the model is maybe 20% of it. One layer in here even rewrites the AI's own memory behind your back. Let's open the whole thing up. A cleanest one-liner. The model generates text, the harness decides what that text can touch. Picture the model as a brilliant brain in a jar. It can think, it can plan, it can write you flawless instructions. But it has no hands, no eyes, no memory. The harness is the body. And here is what surprises people. That brain has amnesia. The model is a stateless function. Tokens in, tokens out. Nothing remembered between calls. The AI you haven't been chatting with. Every single reply, it silently rereads the entire conversation from scratch like it's seeing it for the first time. No memory and no hands. Those two gaps are the entire reason the harness exists. Everything else is the harness covering for them. So how do you get an agent out of a stateless brain? You put it in a loop. Here is the whole engine in about 5 lines. The harness sends the model the situation. The model replies with one of the two things, a final answer or a tool call, a structured request that says, run this for me. The harness runs it, adds the result to the conversation and sends everything back. Look, act, observe, again and again, until the job is done. Researchers call this react, reasoning and acting, interleaved. A chatbot answers once, an agent runs this loop 10, 20, 50 times to finish real work. Let's zoom into that tool call because it's subtler than it sounds. The harness hands the model a menu of tools, each just a name, description, and typed parameters, a schema. The model never runs anything itself. It emits a structured block, call edit file, with these arguments. And the harness does the actual work, then hands back the result or the error. The model is basically an intern with brilliant ideas and zero keys. It can only ask. The only choice, propose, never execute, is the foundation of everything safe about agents. Remember, the model is stateless. So before every turn, the harness rebuilds the entire prompt from nothing. It stacks together the system prompt, who the agent is, the tool menu, the relevant files, the history so far, and the latest result, and ships all of it every loop. Deciding what earns a spot in that stack is its own craft, the context engineering, deep enough that it's got its own episode. Here, just hold this. The harness is the model's working memory, assembled by hand every single step. But that memory has a ceiling, a fixed token window, often around 200,000 tokens. Long tasks blow right through it, and resending everything each loop gets expensive. So the harness pulls two tricks. Prompt caching. The stable front, system prompt, tools gets cached, cutting the cost of resending it by up to 90%. And the compaction. Remember the memory rewrite I promised? When the window fills, the harness quietly summarizes the old turns into a tight recap, keeps the key facts and discards the rest. That's why an agent can grind for an hour and never lose the thread. It's editing its own memory as it goes and you never see it happen. Now, you are about to let this thing run commands on your machine. So every tool call hits a gate first. Reading a file, searching, harmless, auto-approved. Editing a file, changing state, pause, ask the human. Something destructive, delete, force push, curl a script into a shell, blocked or escalated. Modern harnesses even run a fast classifier to sort actions into those buckets automatically. The model proposes, harness disposes. That gate is the whole difference between autonomous coding agent and unsupervised intern with pseudo. Some jobs are just messy. Gripping the whole code base, reading 40 files to answer one question, do that in the main conversation and you bury the actual goal under noise. So the harness spins off a subagent, a second model instance with its own clean, empty context. It does the messy digging in isolation and hands back only the answer. The noise stays quarantined, the main thread stays sharp. And because they are independent, you can fire off several at once. So far, the tools are local, but real agents need GitHub, databases, browsers, your internal systems, and you do not want to hand build an integration for each one. That's what MCP, the Model Context Protocol, fixed when it landed in the late 2024. Think USB for AI. Your harness is the host. It speaks one standard protocol to MCP servers and each server exposes its tools the same way. Write a server once and any MCP aware agent can plug in. That's how the toolbox grows without ever touching the harness. One layer people forget. Not every decision should be the AI's. Hooks are your code, plain, deterministic, fired at fixed moments in the loop. Auto format after every edit. Run the tests after a change. Hard block a commit to main. This is the boring, reliable scaffolding wrapped around this smart, unpredictable model, and you want both. Step back, because this flips how you should think about AI. Everyone argues about which model is smartest, but take one model and drop it into a weak harness versus a strong one. No memory, clumsy tools, bloated context versus a tight loop, clean context, sharp tools, and the same brain goes from barely functional to shipping real software. Models are converging and getting cheaper. They are commoditizing. The harness is where the lasting product lives, which is exactly why harness engineering is the hottest skill in AI right now. So, how does a harness go wrong? Four classic ways. The loop runs away, no budget, and it burns through your money chasing its own tail. Context rot. The window fills with junk and the model gets dumber the longer it works. Tool sprawl. 50 vague tools it cannot choose between. And over permission. You auto approve everything, and one bad call wipes your repository. A great harness is really just the absence of these. Tight loop, clean context, few sharp tools, safe defaults. So there's the whole machine, a stateless, hands-free model, wrapped in a loop, fed a hand-built context, reaching the world only through gated tools, MCP and hooks, remembering through compaction, scaling through subagents. The model thinks, the harness acts. Run Claude Code now and you will see every layer of it working. If this made the whole thing click, hit like and subscribe for the rest of the series. See you in the next one.